we'll discuss about this Kirchoff's law, where it is applied. Kirchoff's law. There are two Kirchoff's laws. First one is Kirchoff's current law, and second one is Kirchoff's voltage law. So where it is applied? This Kirchoff's law is applied to find out the current or potential difference or resistance of the wire. Maybe equivalent resistance also. As after Ohm's law you studied combination of resistance. There are two types of combination of resistance, series combination and parallel combination. From that also we can find out. But here in this Kirchoff's laws there is a network, there is a loop, there is a junction. Means we can find out current across any branch or potential difference between two ends of the conductor of that branch or equivalent resistance of the loop. These things we can find out with the help of this Kirchoff's laws. Now we'll go for the first law, that is Kirchoff's first law. Kirchoff's first law. This is also called as KCL, means Kirchoff's current law, or this is also called as Kirchoff's node law. Kirchoff's node law. Now, Kirchoff's node law or Kirchoff's junction law, all names in short form I have written. Kirchoff's first law is known as Kirchoff's current law, Kirchoff's node law, Kirchoff's junction law. Before going to this first law, we should know what is the node. Node is junction. Means, as we know railway junction, means there are the two railway tracks. There is only one track. One track is split into two tracks. Like that, current is passing in one branch. From that, in two branches, that current is splitted. But from some particular point, that point is called as node. That is called as junction. After that, what is Kirchoff's law? I will explain. Before that, Kirchoff's voltage law. Kirchoff's second law is called as Kirchoff's voltage law, or this is also called as Kirchoff's loop law. Now the word comes loop. KLL is Kirchoff's loop law. Now here as we saw node law or junction law, and this is loop law. Now what is node? What is loop? Before that, what is network? Means network. Network is a circuit which consists of source and some circuit elements. Means just I am drawing here network. Network. You see, I have some source. This is battery and source. Again, some constituent elements, circuit elements. For example, this is resistance or capacitor, whatever. This is called as a network. Now, loop. See, what is loop? Loop means a circular loop. Generally, we are telling circular loop. Means this network I can make into closed path. Means loop is a closed path of a network for the flow of current. So see, this only how I am closing. This is the source, here is the resistance, here is the capacitor. Again, something circuit element I can connect. Anything. This is called as loop. Loop. After that, junction. Now, what is the junction? Junction means this circuit element I can divide into two parts, something like this. See, whatever current is flowing from this positive terminal of battery, current I, some current is going here and some current is passing here. Means at this point current gets splitted. junction. This is called as a junction. Means this thing we have to figure first. What is junction? What is loop? And what is network? Network is a means it is a combination of circuit elements. So some circuit elements like resistors and capacitors. Means loop. This is the one network only closed path for the current. This is loop. Now junction, in that where one point is there, from that current gets split, is called as loop. Now these basic elements we know. Now coming towards first law, Kirchoff's first law. What is this? See here. Current coming across one point is taken in one direction, and current leaving from one point is taken as a negative direction. Means both are in opposite directions. One is coming in one direction and the other is going in another direction. So signs are there. See here I am taking one current. This is the node. Current is coming I1 here. Second current is coming I2 here. Third current I3 is coming at this point. From this point, some current here I4 is outgoing current, leaving current, and this I5 is also outgoing current. Means what is Kirchoff's law states? Algebraic sum of current across the node, across the junction is 0. Means I can write this equation in the form of equation summation I is equal to 0. Means summation I is equal to 1 to n, whatever number of currents are there. So summation I is equal to 0. Means algebraic sum of current at the junction is 0 is called as Kirchoff's first law. Means algebraic sum, I am talking about algebraic sum. In that, here incoming current is taken as positive. Incoming current is positive, whereas outgoing current is taken as negative. These are some sign conventions. In this, I1 is incoming current, yes, I2 is incoming current, I3 is incoming current. Am I right? Means these three currents are taken as positive incoming. So I1 plus I2 plus I3, these are incoming currents. While I4 is outgoing. Same, I5 is also outgoing. So it's taken as a negative. My 4 minus I5 is equal to 0. Summation of current is 0. The algebraic sum of current at the junction is 0. So we are getting this. This is about Kirchoff's first law. Now coming towards Kirchoff's second law, that is Kirchoff's voltage law. See, what is this? I will make a statement. Kirchoff's second law states that this is across loop, because this is loop law, not junction law. So algebraic sum of EMF and potential difference across the loop is 0. See my statement. Algebraic sum, which means this is the here. This is the loop. Means in this totally we have 3 loops. That is A, B, C, D, E, F. And second loop, this side, A, B, E, F, A. Means from where we are starting, again we are going there only. Means what is this? See, at steady state, whatever potential difference or what that potential difference or voltage, EMF at the point is same. It's constant, it's not changing. Means even we are pressing the circuit and coming at the same point, returning to the same point. That point voltage is the same only. Potential difference is same only at that point. So this is the second term. So this is one loop A, B, E, F, A. While this is another loop B, C, D, E. Sorry, B, C, D, E, B. This is third loop. Like that we have loops here. Now here are some sign conventions. Actually the thing is that in across this branch, this is the battery or cell, whatever cell is there. This current I1 is flowing here also. So in this branch also I1, and from this I2 is flowing across this, and here I1 also, I2 also. So current across this is I1 plus I2. So here only I1 current, means I1 current is flowing across this loop, whereas from this loop I2 current is flowing. This is the thing. So for this also some sign conventions are here. So what are the sign conventions? Very important sign conventions of Kirchoff's voltage law. Sign conventions. So see, in this, as we are traversing the circuit, is pressing the circuit, and the direction of current both are same. Means what I am telling, this is the direction of current I, and this is our traversing. We are traversing in the same direction. Means current is flowing from A to B, and we are also, means we are considering loop A, B, E, F, A. Means our traversing means we are walking, not physically, mentally we are walking like this. And current is also same direction. If both are same, means direction of current and traversing of the circuit, if both are in same direction, then potential difference IR is taken as negative. That is taken, potential difference IR is taken as negative. This is first sign convention. Now second sign convention means, see, direction of current is in this direction. Direction of current is in this direction, and we are traversing in opposite direction. Means we are walking from B to A. Instead of considering a loop A, B, E, F, we will consider loop F, E, B, A, F. Means from A to B we are traversing. The direction of current is A to B. Both are in opposite direction. Means our traversing is in this direction. We are traveling like this. So here IR, this is taken as positive. Potential difference is taken as positive. This thing. After that, third sign convention. Means this is about EMF of the same. EMF means from negative terminal, if cell is from negative to positive, this is negative, positive. It means we are traversing like this only, negative this thing. Then only we can solve numericals problems based on this Kirchoff's voltage law. So we will apply for this loop only as per the sign conventions. Okay. So for this, just I will delete this part. So see, I am applying the sign conventions. We will take a loop. Which loop? A, B, E, F, A. That only. So A, B, E, F, A. Means from first point to again last point. That is only first point. A to A. In that. See, from A to B we are traversing. Direction of current is also A to B. Both are in same direction. So IR is negative. So we have to write IR. I is I1. R is R1. Again, from B to E we are traversing. So IR. R is I1 plus I2. Not only I. Into R. That R is R5. So we are traversing from B to E and direction of current is from B to E. Both are in same direction. So IR is taken as negative. So minus I into R. Again, from E to F, we are going from E to F and direction of current is also E to F. Both are in same direction. So IR is taken as negative. So minus IR. What is I? First current I1. R is R3. Again, from F to A, there is a cell. From negative to positive. Means we are going from negative terminal to positive terminal. So EMF is taken as, here I will name this EMF as a E1 and here I will name as a E2. So EMF E is taken as plus E1. E is equal to 0 because algebraic sum of EMF and potential difference is 0. So we apply here. So we can write this statement like this also. Means minus I1 R1 minus I1 plus I2 into R5 minus I1 R3, and this term I will send this side, so this becomes minus E1. So this minus is plus. So we can write this. This is our equation 1. Similarly, we can apply for this also. For loop, I will take this B, C, D, E, B. This loop we have to apply. See, we are traversing from B to C and direction of current is C to B. Both are in opposite direction. So I am taken as positive. So I am applying this IR. I is I2. R is R2. I2 R2. That is positive. Now next, C to D. B to C. C to D. There is a cell. Means from positive to negative we are traversing. Means EMF becomes minus negative. This thing. Positive to negative. So minus E2. Again, D to E. Direction of current is in this direction. We are traversing in opposite direction. So IR is positive. So plus IR. I is I2. R is R4. Similarly, E to B. Again, we have to go there only. So current is in downward direction and we are going in upward direction, opposite direction. Both are in opposite direction, so IR is positive. So our current is I1 plus I2 and resistance is R5 is equal to 0. So I will send this negative term there. So I am getting this equation I2 R2 plus I2 R4 plus I1 plus I2 into R5 is equal to E2. Yes, am I right? Means we are getting this second equation. So from this we can solve current I1, I2 or EMF like this we can solve. Means you have to apply these sign conventions for these groups in this way. These are the sign conventions. Okay. Now after this we will take one problem based on this KVL only. Kirchoff to this